Hello students, in additional exercise problem 4.19 of chapter 4, we have an electron emitted by an heated cathode and accelerated through a potential difference of 2 kilovolt enters a region with uniform magnetic field of 0.15 Tesla. Determine the trajectory of the electron if the field is transverse to its initial velocity, means if theta is 90 degree, or if it makes an angle 30 degree with initial velocity. So we are asked to find out the nature of trajectory of electron for two different angle values. Let us try. Very first thing here we will have to do is we should be knowing with what speed electron is entering into the magnetic field. So for that we can use this data that 2 kilovolt is the potential difference. So if it is 2 kilovolt, what we can do is we know that the potential energy QV is equal to kinetic energy half mv square. I'm sorry, this should be voltage, so capital V. So first thing we should do is find out speed of electron. So 2 eV by m. Make V subject of formula here. What you will have? Charge is electron, so Q is E. Okay, V is potential difference and m is mass of electron. And under root of this will give us speed. So very first thing is find out speed of electron. Now once you have speed of electron available, what you can do is consider first case. First case is when uh, electron enters the magnetic field in transverse manner, so theta is 90 degree, and then centripetal force mv square by r is provided by magnetic force, that is qvb. So how much is r? R is equal to mv by qb. So in this case electron will follow circular path, circular trajectory it will follow. Earlier in theory also you were explained that if you consider this sort of magnetic field. Now what is the nature of this magnetic field? Magnetic field lines are going inside, and in such magnetic field if we consider a particle to be entering like this, say q particle is coming with velocity v, what will happen? So this particle, if it is positive charge, will follow this path and go back. How much is the radius of this trajectory? This radius is given by this formula. Okay, so what will happen in first case? If the electron is entering perpendicularly, then the path followed will be circular and the radius of the path will be r, which is mv by qb. But what if the electron is entering at some other angle, say 30 degree? So now, again if we consider the same magnetic field, now the magnetic field is again considered to be going inside, and now the particle is not entering at 90 degree, rather the angle is something else, let it be 30 degree. Let the path be, I'll have to take different drawing, let me change it, sorry. So let us consider this is North Pole, this is South Pole, and so these are the field lines, and now I consider the particle to be entering like this. Let this angle be 30 degree. Okay, this is particle q entering with velocity v. Now whenever particle enters at angle other than 90 degree, it will not follow straight path, it will not follow circular path, it will have helical path. What do you mean by helical path? Helical path is path like this. Okay, particle will follow this type of path, and for this type of path there are two characteristics. First is radius of this path, second one is pitch distance, say x. So if you want to describe any helical path, you will have to mention these two parameters, and in this case, we'll need these two parameters. So radius is again easy. I will take centripetal force mv square by r as qvb sine theta. Now sine theta is not 1 because angle is not 90. So what is r equal to? So you will have sine theta here also. So mv sine theta by qb. This will give you radius. Okay, and then you will have to find out frequency also. In cyclotron topic, you had a formula for frequency. So go back to that formula, find out frequency, and using frequency, find out time period. Once you have time period, you can take x component of velocity to be v cos theta, which is x by t, and then x is equal to v cos theta into t. So this will give you pitch distance. Pitch distance is distance between two turns, and then you can describe that it will follow which kind of helical path. So that is how you will be able to describe the trajectory if the angle at which particle is entering into magnetic field is 30 degree. Thank you.